Hey team, I'm Maddie. Welcome to Science Side Up, and today we're going to start talking about climate forcing, specifically carbon dioxide's climate forcing. I've broken this video down into two parts because it was getting a little long trying to do it in one, so we'll break it up between two. But the question that we're going to be looking at for this video and the next video is what happens to Earth's surface temperature if we double the amount of carbon dioxide in the atmosphere. We already know, we've already talked about how carbon dioxide and other greenhouse gases act to heat up Earth's surface, right? If we've got Earth down here, and our sunlight that comes in, we know that when this radiation comes in, it's absorbed by the Earth, which then gets re-emitted back up and absorbed by carbon dioxide, which sends it back down. So you get a loop there, and eventually you'll get total emission back out of the Earth to space. So we know that the way carbon dioxide heats the Earth's surface is by absorbing and re-emitting that electromagnetic radiation back down to the Earth's surface. Some will escape upwards. Check out like the first couple videos if you don't remember this. So I think it kind of makes sense that if we just add more CO2, then we'll get more of this process, right? The more things that are there to kind of intercept that outgoing long wave radiation from the Earth's surface, the more energy, the more radiation that's going to get redirected back to the surface, thus heating up the surface. So conceptually, I think we've got a handle on what's going on, but I actually want to put some numbers to it. So what we want to do here is figure out how much more energy is going to get redirected back to the surface, right? So just because we say double the amount of CO2 doesn't mean we're going to double the temperature or double the energy being redirected downwards. So there's not necessarily that like linear, nice proportional relationship. So what we're gonna look at is this idea. So delta F, fun fact, in math and in science, a triangle, or the Greek capital letter delta, is usually read as the word change. So the change in F, which F is going to be our forcing, so the change in the forcing, or the change in the energy, is going to equal a term I'm going to call radiative efficiency. Radiative efficiency. And we're going to multiply our radiative efficiency by the change, again, that Greek letter delta, in parts per million. Okay, so let's kind of talk about this little equation in words. All right, so the delta F, that's our change in climate forcing. And this guy should have units of like watts per meter squared. So it's gonna have, this is going to be like energy, or excuse me, yeah, it's gonna be like energy. It's a power per area, but you can think of it as energy. So kind of how much energy is getting re-radiated back down to Earth's surface. Radiative efficiency, this is efficiency, right? If a bunch of energy goes up to my carbon dioxide molecule, how efficient is it at absorbing that energy and re-emitting it back downwards? So by radiative efficiency, we'll just call that how good is CO2 at absorbing and re-emitting energy. And then last but not least, this delta ppm, or the change in parts per million. So how much more CO2 do I have now? So the change in CO2 concentration. Ran out of room there. I was trying to write into the wall. Okay, so very cool. Remember, we're asking the question, what happens to Earth's temperature if carbon dioxide is doubled? So what we're gonna do in the second video is take this, the change in the climate forcing, so that change, and we're gonna think of it as energy, and turn that into temperature. So this is what we're trying to solve for. Change in CO2 concentration. Okay, well, we said we wanted to double it, right? So this should be a number we can pretty easily look up. And then radiative efficiency. Okay, where are we going to get that? How do you calculate it? That kind of thing. Luckily for you and me, this radiative efficiency is something that with the right equipment and patience and expertise, you can measure. So the experiment will probably look something like this. You have a container that only has carbon dioxide in it. You put energy through it, and then you can measure how much energy comes out the top. So if you know what goes in, what comes out, you know how much is redirected downwards. That would tell you something about the efficiency. For us, there was a number in a textbook that I have. So that's the number we're gonna use. I'll put a link in the description to my source there. So it's 0.0155 watts per meter squared per parts per million by volume. A quick little unit sanity check. My change in parts per million, that's gonna have units of parts per million by volume, and that's by volume as opposed to by mass. Both of those are measuring how much CO2 do I have in this box. It just depends on how you define the box. Don't worry about it if you don't understand the difference. It's not really important here. So cool, we've got this number here, and our units are gonna work out, because if I multiply watts per meter squared per parts per million by volume by something with units parts per million by volume, I will get watts per meter squared, which is what we're looking for. By the way, quick math and science hack for everyone, double check your units. It'll help keep you sane. So then the last thing we need to do to get a number is figure out how much the change was. I know we want to double, but can we put a specific number in units of parts per million to that? Okay, pause real fast while I erase the board and get some more space to work with. A very common standard in the scientific literature experiment to do is to take the amount of carbon dioxide that was in the atmosphere before the Industrial Revolution and then double that. So if you ever hear the phrase a carbon doubling experiment, or even this question that we are asking, what happens to Earth's temperature if you double CO2? Usually the reference point, the starting point, is pre-industrial revolution concentrations of carbon dioxide. The number we're gonna get, I grabbed from a NASA website. I will link it in the description so you guys can know I'm not lying. And so it says that our pre-industrial revolution levels of carbon dioxide were 280 parts per million. So if we were going to double it, right, to get to 560, which is not what we're at right now. We're somewhere in the 400s. I just don't carry that number around in my head. But if we were to double it up to 560, then the change would be a change of 280. So the value that we're gonna use for our change in parts per million is 280 parts per million by volume. I'll put that little V there. Excellent, wonderful. So then all we've got to do is multiply this number by that number and we'll get our change in climate forcing. So to do that, we get a delta F, change in climate forcing, is 4.34 watts per meter squared. Awesome. So now we have that change in the energy, and next video, we'll take this change in climate forcing and turn it into a change in temperature, answering the question, what happens to Earth's temperature if the carbon dioxide levels are doubled? Okay, team, that's all I've got for you today. I hope you liked this video, and I hope you'll join us next week when we kind of finish this problem. So I hope you are well, and those you care about are well. Please like, subscribe, don't forget to be kind, and I will see you all next time. Bye, team.